This is Chapter 4, Carbohydrates, Sugars, Starches, and Fiber for Nutrition 230, Smollen's third edition of Nutrition Science and Applications. So carbs in the modern diet. Carbs are the basis of most modern diets, and often people think of carbs as just being starch. On the other hand, carbs are really starch and fiber and sugar. So they're found in most foods aside from pure oil and pure meat. Carbs in whole foods such as fruit, dairy, or whole grains are in their natural state. We refine carbs by removing some of the fiber and some of the protein and vitamins and minerals, and we separate the carbs from their vitamins, minerals, and fiber, creating a really energy-dense, less nutrient-dense food. These are the carbs we want a little bit less of in our diet. So here are some different sources of carbohydrates. So as you can see, carbs will span the spectrum of Choose My Plate. They're in every food group aside from our oils, and we don't find them as much in animal products as we do in vegetable products. But really a vegan, aside from the oil that they're consuming, is eating mostly carbohydrates in their diet. Somebody who eats more animal protein might eat a slightly lower carbohydrate diet. So we can refine carbohydrates and take a really great food in its natural state and turn it into empty calories. So we can take some really healthy corn on the cob and strip it of its fiber and turn it into cornflakes. Then we can take sugar cane and refine that by spinning it in a whole bunch of cycles to become refined sugar. And then we can put that refined sugar on top of the cornflakes to make frosted flakes. So there we had two pretty healthy things in their natural state turned into a very refined product. When we look at whole or unrefined grains, there are three components. There's the endosperm, which is the starchy part, the bran layers that contain most of the fiber and are a good source of vitamins and minerals, and then the germ that's located at the base of the kernel, and that's the embryo where sprouting occurs. It's a source of oil, and it's also really rich in vitamin E. Refined grains are made largely from the endosperm and are mostly starch. Refined grains are often enriched, which is that's a law in the U.S. to enrich our refined wheat grain products. So they're enriched by adding back thiamine, riboflavin, niacin, and iron, and then they're also fortified with folate. And we'll talk a little bit later in the semester about why fortification of folate is so important for women of childbearing age. However, they don't contain the magnesium, the vitamin E, some of the other B vitamins, or other nutrients such as fiber that whole grains contain. So they're a little bit lower in protein, a little lower in vitamins and minerals, and then also lower in just overall health. So we're concerned about refined grains because of their empty calories, as well as our added sugars in the diet, especially added sugars from beverage consumption. It's really easy to overconsume calories in beverages, and as you can see here, having the same amount of calories from natural sugared sources such as kiwi versus added sugar sources such as soda is going to result in a really different micronutrient composition. So we want to make sure that we're really having ample amounts of natural sugars versus added sugars if we want some sweetness in our diet. So starch is the result of photosynthesis. So unlike us, we need some substrate such as carbs, protein, and fat in order to create energy in our body. Plants can use the sun's energy in order to create starch for storage calories. Plants most often convert glucose to starch, and so when a human eats plants, they need to digest the starch and convert it back to glucose. And then we can absorb it and metabolize it, as we talked about in Chapter 3, through the citric acid cycle and electron transport chain if we're talking about aerobic metabolism, or through glycolysis and anaerobic metabolism. So there are simple carbs and there are complex carbs. The basic unit of a carbohydrate is a sugar molecule known as monosaccharide. There are 3 monosaccharides in our diet, including glucose, galactose, and fructose. glucose is the type of carb we find in blood sugar. And then fructose is the type of monosaccharide that we find in fruits and vegetables typically. And then galactose is never really found alone. It's typically attached to glucose to create lactose or milk sugar. So as you can see here, all of the molecular formulas are going to be C6H12O6. They're just created in a slightly different fashion. As you can see here, this is where organic chemistry learning comes into play a little bit. And so they have slightly different properties in terms of taste and how they interact with other molecules. Disaccharides are each monosaccharide combined with an extra glucose. So sucrose is glucose plus fructose. When we look at sucrose, it's the only sweetener in the US that can be labeled sugar on the ingredients list. So anything else on the ingredients list that is a simple sugar is actually labeled as something like, fructose or dextrose or maltose, and so or something syrup. So you won't see anything that says sugar on the label unless it's sucrose, which is table sugar. The chemical reaction that breaks sugar molecules is called a hydrolysis reaction. So when we talk about using enzymes such as salivary amylase or pancreatic amylase or sucrase or lactase or maltase, in order to digest our starches and sugars, we're going to hydrolyze those bonds, which means we add water in order to break apart the bonds. On the other hand, when we store carbs, we're going to perform condensation reactions, which removes water in order to combine those bonds and create long chains of carbohydrates again, which are going to be glycogen that we store in the liver and that we store in the muscles. Disaccharides include maltose, as we mentioned. Maltose tends to be a product of digestion of starch, so it's kind of the last step between forming glucose from starch. Maltose is also found in certain products like malt liquors and malt balls, malted milkshakes. It has a little bit of a chalky taste. Sucrose, as I mentioned, is going to be the disaccharide that's table sugar. And then lactose is going to be made of glucose plus galactose. And you can see that the bond looks a little bit different with lactose. Lactose does require a different enzyme to break it apart. Some people don't have enough of this enzyme in their body, which is lactase, and those people would be considered lactose intolerant. Here's some examples of condensation and hydrolysis reactions, which you've all learned in Bio 107 and in organic chemistry. So hydrolysis reactions are caused by adding water to a substance in order to break it apart, and condensation reactions occur by removing water from a substance. We require enzymes to do both of these things, and when we talk about digestion, we're going to talk about the enzymes of salivary amylase, pancreatic amylase, and then sucrase, lactase, and maltase in order to digest all carb molecules. Complex carbs are made up of many monosaccharides linked together in chains. Oligosaccharides are short chains of less than 10 monosaccharides. So when we look at oligosaccharides, any carbon chains of carbohydrates that are between 3 and 9 molecules are considered oligosaccharides. And then polysaccharides are going to be 10 or more monosaccharides linked together. Dietary fiber is a complex carbohydrate that bonds cannot be broken by human enzymes, so it cannot be digested or absorbed by the body. There are two types of fiber. There's insoluble fiber that doesn't dissolve in water, and then there are soluble fibers that dissolve in water. Each of these has slightly different outcomes. We can think about soluble fiber as helping to increase the mass of food in our GI tract, make things move a little bit more slowly, help us feel fuller for longer, and then also help to lower total body cholesterol. Insoluble fiber, as I mentioned, doesn't dissolve in water, and insoluble fiber is going to cause things to move a little quicker through the GI tract, and it almost acts as a little brush, kind of cleaning everything out. Fibers can be added to processed foods to thicken and can also reduce fat and calories. So you might see some cereals or bars or things like that that are quite high in fiber. You do need to watch your fiber intake and make sure to balance it with your water intake, because a high fiber intake without high water intake can end up leading to constipation and other discomfort. Fiber sources are going to include mostly whole foods. So good sources of soluble fiber include mostly fruits, as well as the seed, flaxseed, and oats. When we look at good sources of insoluble fiber, it's a lot of vegetables, and as well as nuts and seeds, the skin of the apple, corn, and whole grains, such as whole wheat bread. So when we look at the digestion and absorption of carbohydrates, I've mentioned the chemical digestion a few times. So in the mouth, the salivary amylase is going to start carbohydrate digestion by hydrolyzing the bonds. The salivary amylase continues to work until the stomach. In the stomach, the salivary amylase is deactivated because proteins are denatured by stomach acid. And so we see that enzymes are proteins, and so anything that's working in the mouth typically doesn't work in the stomach because it becomes denatured. So nothing really happens in the stomach there. In the small intestines, first, in the duodenum, the pancreas secretes pancreatic amylase and continues starch digestion. Then, in the small intestines, near the villi, we have the disaccharidases. And the disaccharidases include lactase, which digests lactose into glucose and galactose. We have maltase, which digests maltose into glucose and glucose. And we have sucrase, which digests sucrose into glucose and fructose. Then glucose, fructose, and galactose can be absorbed into the mucosal cells, where they then will head to the venule, to the vein, to the portal vein, and to the liver. When we look at the large intestines, the indigestible carbohydrates keep going through the large intestine, where they're partially broken down by bacteria, where they can form some short chain fatty acids and some gas, which I'm sure you've all experienced after eating some high fiber foods. And then the remaining fiber is excreted in the feces. So although fiber never enters our body, fiber is going to be important for maintaining digestive function. As I mentioned, the enzyme lactase, which is that disaccharidase located in the small intestines, it's needed to digest lactose, the sugar found in milk. If it's not digested in the small intestine and lactose continues on through the large intestines, it can cause cramping, abdominal distension, as well as diarrhea, and we call that lactose intolerance. And different people have different levels of lactose intolerance and can tolerate a different amount at a time. There's another indigestible carbohydrate called resistant starch. Resistant starch is actually created when we heat up some starchy food and then let it cool. So there's resistant starch in things like potato salad or macaroni salad or colder rice. So if you've ever heard somebody say that there's less calories in food that's been in the refrigerator overnight versus when it's first cooked, that's due to resistant starch. It's not too much of a difference, but a little bit. Fiber and oligosaccharides are also not digested in the small intestines, but they do affect transit time, types of microflora that are available, the amount of intestinal gas that's present, as well as nutrient absorption. So indigestible carbohydrates can help keep you fuller longer, and help lower the glycemic index, or how quickly your blood sugar rises after a meal, by creating more surface area. So as you can see, there's a little bit slower release of the carbohydrates into the system in a high fiber meal versus a low fiber meal. So you can pretend the meal on the left is something like oatmeal for breakfast, and the meal on the right is something like Captain Crunch for breakfast. And so that Captain Crunch is going to cause you to, absorb the same amount of calories, but a lot quicker. And so you feel a little bit hungrier a little bit sooner. In part 2, we're going to get to the transportation of carbs around the body, as well as metabolism of carbohydrate.